All right, hello everyone. Thanks for joining in. And today we'll be going over and exploring the fundamentals of computer science organization and architecture and focusing on the CPU and explaining what it does and the importance of it. So if you're ready, let's go ahead and begin and get to it. Okay, so our next slide is what is computer organization and architecture? What's the importance, the role, the relationship to the hardware. So computer organization architecture is all about how computers are designed and how all the internal parts that work together they're used to run the programs. So the architecture side focuses on what the computer does, things like the instructions, the set, how data is processed, and what CPU is capable of doing. The organization focuses on how it's actually built, so the components like the CPU, the memory, the input, output devices, they're all connected and they interact with each other. And so this is important because it directly affects how fast and efficient a computer is going to be. So everything from opening apps to running games depends on how well the system is designed. Overall, it plays a major role in computer systems by connecting hardware and software, making sure everything runs smoothly and also efficiently. All right, so next is what is the central processing unit, or CPU for short. So the CPU is the primary component of a computer responsible for executing instructions and performing like calculations. It's almost like the brain of the computer. It coordinates the activity of other hardware components. And so while it's processing instructions from the software program, so the CPU allows it to retrieve instructions from the memory, it will interpret them, and then perform the required operations from it. Because it controls data processing and system coordination, the performance of the CPU also has a significant impact on the overall speed, but also the efficiency of a computer system. So now we have the control unit, so CU for short. This is basically responsible for directing the operation of the CPU. So its primary function is to manage the execution of instructions. So it'll do that by retrieving them from the memory and then interpreting what actions need to be performed. So the control unit also does not perform the calculations by itself, but instead it'll send coordinates of the actions of other components within the processor. So after it decodes the instruction, the control unit sends control signals to different parts of the computer system, including like the arithmetic logic unit, ALU for short. So, and then it also sends to the registers, the memory. So these signals ensure that the correct operations are carried out in the proper sequence during the instructions execution. And so now we have the arithmetic logic unit, ALU, as we were saying in the previous slide. So the ALU is the component of the CPU responsible for performing the arithmetic calculations and the logical operations. So the arithmetic functions include operations such as things we all know like addition, subtraction, multiplication, division. Logical operations involve comparisons such as determining whether one value is greater than another, or by evaluating conditions using operators like AND or OR. So the ALU also processes data provided by the registers or the memory, and by doing that, it produces results that are stored back into the system. Because most computational tasks require mathematical or logical processing, the ALU plays a critical role in executing the instructions within the CPU. Okay, so next we're going to be talking about how the CU and the ALU work together. So the control unit and the arithmetic logic unit work together during the instruction cycle to process program instructions. This process basically typically will begin when the control unit fetches an instruction from the memory and then decodes it to determine the required operation. Once that the instruction is interpreted, the control unit directs the appropriate components to carry out the task. If the instruction requires a calculation or comparison, the control unit sends the necessary data to the ALU. So then the ALU will perform the operation and will return the result, which is then stored in either the register or the memory. So this coordinated process allows the CPU to execute instructions efficiently and maintain the correct flow of operations within the computer system. All right, next we'll be talking about instruction pipelining. This is basically a technique that's used in modern processors to improve the performance by allowing multiple instructions to be processed at different stages simultaneously. So instead of waiting for one instruction to complete before starting the next, pipelining will divide then the instruction execution into different stages so that several instructions can be in progress at the same time. This approach significantly increases the instruction throughput and improves CPU efficiency. By overlapping the different stages of execution, the processor can complete more instructions within a shorter period of time, leading to a better overall system performance. All right, so pipeline instruction process example. So a typical pipeline consists of several stages, including the instruction fetch, instruction decoding, the execution, the memory access, and then the write back. So during the fetch stage, the CPU retrieves the instruction from the memory. In the decode stage, the instruction is interpreted. From there, the executed stage performs the required operation, while the memory and write back stage stores the results. So for example, while one instruction is being executed, the next instruction can then be decoded, and another instruction can be fetched from the memory. This overlapping process allows the CPU to handle multiple instructions at once, improving process efficiency and also reducing idle time within the processor. Alright, now we have reached the end of this video. I hope this video was helpful in teaching you more about the central processing unit and the details about it and how it serves to function in hardware. Please feel free to like, comment, share, and subscribe, and stay tuned for the next video. Thanks.